Okay, now members, let us focus on to this question. Is still about the power idle. So the force opposing motion of a car is this Newton's, where V is the speed of the car in meters per second. The power that is required to maintain a certain speed of 20 meters per second and 30 meters per second is 6.3 kilowatts and 15.3 kilowatts respectively on a level ground. Find the values of alpha and beta, and part B, power required for a steady speed of 40 meters per second. So, in simple terms, now what we do, you know, our first velocity, V1 is 20, and the power to maintain that speed is 6.3 kilowatts. You know that every watt is having 1,000, every kilowatt is having 1,000. So, convert now this power to watts. Those are the standard international units for power. So multiply here by 1,000, we get this. Now you know that for every V and then the power, there is a force, the attractive force. The attractive force that is going to be put in that car is given by the power over the velocity at which it's moving. So you get this P divided by this, and that will be the force. So when it's at this speed, this will be the force at which it will be going, the attractive force. The second velocity is 30, then the power required to maintain that 30 is this. So giving us that, so our P, if the power, now the attractive force for this velocity, we get the power and that velocity, which will be there, and then we get that as 100. So the attractive force we need when the velocity is this, and this is the attractive force we need when the velocity is that. Now, we come and draw our diagram here to show all that we've been talking about. Okay, so this is my vehicle. Of course, it has a mass m kilograms. I don't know that mass. This is going to be my reaction, and then this will be mg. Now, for every car, it has a force that is driving it forward, which is given by P over V. And then this side, we are having a resistance. Telling us that this resistance is given by alpha plus beta V squared. That's the resistance I'm having. But because they are talking about the speed, so the speed means there's no change in velocity, or it's a constant speed. And whenever you have constant speed, the acceleration is 0. So we say at steady speed, acceleration is already 0. So if we are going in this direction, if that's where the direction we are going, you will see that always our Fr is equal to Ma in that direction. Okay, so the result that we shall get this F, then minus this one, the opposing force, equal to M times 0. So from there you can see that always our alpha plus beta V squared is equal to F. So that is true if we have steady velocity. It means that these two forces are equal. Okay, from there now, you see, now when I have, look at this, when V1 is equal to 20, when my velocity is that, then my F1 is going to be 315 newtons. So now putting in here, I have now alpha plus beta into 20 squared equal to 315. Now you see this will be alpha plus, this is going to be 400 beta equal to 315, and I call this equation 1. Okay, when V2 is 30, my F2 for it is going to be 510. So meaning when you substitute into this formula, we have alpha plus beta into 30 squared equaling to 510. Then we are going to see this is going to give us alpha plus 30 squared, that's 900 beta equaling 510, and this would be equation 2. So if that is our equation 2, then we can come, I think we can see, we can happily solve this 2. So I'm going to say equation 2 minus equation 1. So 2 minus 1. Now 2 minus 1, I have alpha, let me choose here, alpha plus 900 beta equaling 510, then alpha plus 400 beta equaling 315. Then I subtract this minus that will give me 0. So this will give me 500b equaling 2. When you subtract there, we have 195. So from there, our beta is going to be 0.39. So if beta is that, then n will substitute. So we can say from 1 n. So from this one, that our alpha is going to be 315 minus 400 into now beta 0.39. So our alpha is going to be it's going to be 1, 5, 1, 5. It's going to be 1, 5, 9. So those are the values of alpha and then beta. Okay, after getting them, then part B, this was my part A. Then part B, they are telling me power required for steady speed of 40. So when B is 40, they want the power. So of course I come. Of course, if I have that, so means I first get the force. So from here, now my F is equaling alpha plus beta b squared. So if I substitute, so my F is going to be alpha, which is 159 plus beta, which is 0.39 b squared. So now they want me to get the, of course, to get the power. You see that our power is always first times the velocity to get the power. So now what I get first, I first get the force because I have the velocity. Now I need the force. So when B is 40, my force is going to be 159 plus 0.39 into the velocity, which is 40, and that will be a square. And that will give me this will give me 783 newtons. So if I have this, I know that always power is equal to force times V. So my power is going to be now my force, which is 783 times 40. So my power is going to be 31320. These are watts, which we can ably give to kilowatts by dividing by 1000. 31.32. These are now kilowatts. Why are we converting to kilowatts? Because for every velocity, it was given, its power was given in kilowatts. So that's it, members. I wish you well.